So, I'm Santosh Balasubramanian. I run the product team for stream analytics and time series insights, some of our IoT analytics and big data analytics workloads. What I wanted to start the session with is actually ground this in a scenario which one of my colleagues did working with ABB. So, ABB does a bunch of things, and one of the things that ABB does is actually sells transformers. Very expensive to maintain, things which have a very high value for them and the customers. What happens when you have failures in transformers is it not only downtime, it actually impacts quality of service to customers of people who have bought these transformers from ABB. So we said, all right, let's work together. Let us see how advanced analytics can work together with IoT and what kind of insights we can get from this. What we ended up doing is we looked through a lot of data which is coming from these transformers. There's tons of sensors in there. But while doing our research, what we actually found is there's this thing called partial discharge, which comes from the transformers. You can actually put devices around your transformer and capture how much is the partial discharge which is happening. After we did this, we built neural network models, and we started to predict when or what can cause the failures in these transformers. So let us go back again and see what we did. We had a device, we had a business problem. We figured out what kind of sensors can be impacted in order to do analysis on top of it. Took that data, brought it to the cloud using IoT Hub, then used everything from real-time analytics in order to see what is the current state of partial discharges, what is happening, down to machine learning, where we built predictive models and were able to display the end of the results in dashboards, which could be used by folks in ABB to actually think about how we can not just sell devices, but sell services in order for maintenance. Think about the next stage of people who are selling devices can now start selling SLA. I can start selling uptime of my devices as a service because I can start getting this data and using the power of the cloud and all the advanced analytics tools, start predicting things like anomaly detection, demand forecasting, predictive maintenance. And this is not just one of the isolated folks. Aerocrine, actually, I was saying I work on Azure Stream Analytics. One of our first customers, they sell devices which is useful for asthma patients. So you can take this device and it enables you to connect an asthma patient remotely to a doctor who is specific for the purposes of lungs and things like that. So initially they were selling these devices. Actually at Microsoft we have a health center which also has this device, but we don't have any specialist who is there who can treat asthma. So we have this device which enables you to connect. Now what they also do is this device is expensive, so I can measure what are the experiments running on this device, what is the temperature, what is the humidity, what is the environment around this device, because all of these things can impact the quality of the device. So now they sell remote monitoring of the device as a service. So they reinvented their business model. Another thing, NASCAR. I'm just going to go across a few scenarios so you can see how analytics is useful. NASCAR recently took GPS coordinates which is coming from their cars in order to do real-time geospatial analytics to see what is the distance between cars when a crash happens, decreasing the amount of time, like from 30 minutes, I believe, they brought it down to 5 minutes. When a crash happens, what is the order of cars? So these are the experiments that they're running. TransAlta, I think this is the largest wind farm company in Canada. They are also doing things such as remote monitoring, time series databases there, or time series insights, which is a service that they are using on Azure in order to see what is the quality of service that I am providing to my customer, how do I keep uptime and other things. Why I wanted to start with all of these scenarios is in this session, it is not just about IoT or getting data from sensors. We are going to walk through what will it take for a customer to take this end to end. And really, if we think about it, we started with building a lot of these services for the cloud, like Azure Stream Analytics, machine learning, and other things. Advent of IoT, now we know how to connect and get data from these sensors. Next round of innovation is the edge. There is a lot of scenarios where I want to use the power of the cloud for my global training, but I want to be able to do some local processing as well. And I'll go into the details of what that local processing is and hopefully show you some demos today. And then AI. How could I put intelligence in all of these services that I'm talking about? I will actually try to show you a demo of how we are embedding things like anomaly detection directly in our streaming pipeline, so a customer doesn't even have to think that they're using machine learning. So what I thought is I will drive the session through a set of scenarios. Let's assume that you are doing some factory floor maintenance or remote monitoring and things. So the first thing you want to do, I just want to get this data and I want to look at what is the real-time status of what are things happening. Show you how to build that. I want to know how I can detect anomalies and do some alerting. I want to show you that. I want to be able to do some edge processing on top of it, where I can actually do low latency processing. I'm going to show you a demo on that. This is in private preview, so please work with me on, this is not the final state, but certain things. Time series insights. This is all of my IoT data, whether I'm talking about connected factories, connected cars, connected X, Y, Z. All of this is producing time series data. How can I think about not just collecting and storing this data, but also deriving insights and visualizations from it? This is what time series insights is all about. And Ted is going to come and talk about how, of all the data that we have collected and done some analytics, how we can use machine learning with the new things that we have released as well. Hope you find this interesting. We have a lot of things to cover, so one of the things, if you don't mind, I request in the sessions is I will not take questions while there are discussions going on. There might be certain parts where I will be able to take 1 or 2 questions, but at the same time, please look at this nrtpmteam@microsoft.com. Feel free to send any question to this alias at any time that you want. There are people in my team who are basically ready to answer even at real time. And there's also @Azure Streaming. You can tweet any of your questions here as well. All right, so let's start with real-time analytics. I have connected my factories, my cars, my devices to IoT Hub. All I'm doing is I'm streaming data from all of those things. What do I want to do next? I want to look at what is the live status of, let's say I'm selling comfort as a service for this building, of all the environment variables which is there in this building. I want to be able to get alerts when heat in one section of the building has increased considerably because there's a failure in the AC. I want to be able to enrich the data which is coming from this building, temperature, humidity, and things, and start doing some future analysis on top of it. It doesn't need to be real time, but I want to enrich the data in real time. As a lot of folks who have been working in the devices and sensors field know that generally sensors actually think about payload optimization. So they only send ID and value. So how do I augment the data to complete the payload so I can do my analytics? Those are scenarios that we have heard from customers who are using real-time analytics for. I am going to talk about Azure Stream Analytics, a service that we released 2 years back. By the way, anybody familiar with the service? Anybody's heard of it? Okay, there are a few people, but there's a lot also who haven't, so I'll dive a little bit into the basics as well. It is a fully managed stream processing solution in the cloud. What this means is we have basically gone and built a multi-tenant platform as a service solution in which I can start asking questions on data in motion. The difference between data at rest and data in motion, just very quick, I always say this, is think about you're in a parking lot and there are cars in a parking lot. You want to ask how many red cars are in a parking lot. Select star from parking lot where car color is red, right? Or count star. You ask a question, you get an answer, and that's it. The question dies. Now think about this a slightly different way. I am in a highway, and I'm standing at a point in a highway, and I say, cars are zipping through. Tell me the number of red cars which pass this point in a 5-minute window. So this is asking a question on data in motion. Every 5 minutes, you will get an answer. The query never dies. So this is what Azure Stream Analytics is all about. It allows you to ask questions on the data and do complex processing on the data in motion. One of the things that we ended up doing is we focused a lot on developer productivity. So if you look at what are some of the competing products, actually Microsoft has released also in 2009 a product called Stream Insight. Link-like queries you can write. Storm, you can write Java queries. But what we did in Azure Stream Analytics is we removed all the complexity of that and put a SQL-like language. And I will show you an example of that so you will understand what I'm talking about. It is fully managed. You don't have to think about anything else except literally going into the Azure portal and saying how many resources I need to run my logic. It is a pay-as-you-go service. We have all the mission-critical TCOs, reliability, SLAs, which is associated with it. And it is very easy to get started. I assure you, if you have data in your IoT hub, you will be able to create your first live dashboard within 5 minutes. That's how simple that we have actually aspired to make it. So, very quickly, Azure Stream Analytics is looking at data which is coming from things like IoT Hub, or even Event Hub is another streaming service that we have. We also look at data which is coming from blobs, where blobs can be updated and we read those triggers from blobs. You can augment the incoming data in motion with data at rest with reference data. I can call machine learning models as call out to the machine learning service. I can actually, once I do my processing in Stream Analytics, I can write it for archiving purposes to blob storage, Azure Data Lake, Cosmos DB. I apologize, I have the wrong name here, old name of document DB. This should be Cosmos DB. SQL DB, SQL Data Warehouse, Table Store, and a variety of other stores. I want to do real-time dashboarding. We have direct connectors to Power BI, so you can actually do your real-time dashboarding there. I want to be able to kick off workflows and automate workflows. We have connectors to things like service bus, topics, and queues, and event hubs, and we just added Azure Functions, which enables you to do that. SQL, when I said, literally, if you know SQL, you can write your stream processing job. I want to know when the average temperature of this room gets less than 50 degrees, then it's too cold. I can say it in English. If you can represent it in SQL, you can write that logic also in Azure Stream Analytics. For example, select average of temperature from the IoT hub that you're looking at, grouped by room ID. So it's in a tumbling window of 5 minutes. So what we have done is we have taken all of these temporal constructs and we have given you SQL functions on top of it. I'm curious, people who are familiar with SQL here? Nearly everybody. So hopefully when you're done with the session, everybody creates their first streaming job. But apart from that, we have also added things such as geospatial functions that I'm actually going to show you as well. Not only can you do simple things, you can also do complex things with this. Like a lot of times, here is, one thing which people have to think when they're thinking of IoT scenarios, because not always the payload is sent. How do I actually fill missing values? I'm just sending temperature, I'm not sending pressure because nothing has changed. How do I fill in that missing value to create the payload? We have given functions for that in SQL that you can do it. What is the first event, last event in a window? You have functions for that. You have different kinds of windows as well in the language, which I will show you. How do you detect duration of a condition? So if you start thinking about, I had an issue with my pressure valve, and the issue ended at a particular time. How long was that? Things like that you can actually do with the SQL-like language of Azure Stream Analytics. So let me show you a quick demo. I want to make sure you can see it on the screen. That is perfect. So what I'm doing for the demo, let me show you the demo architecture before I do it because it actually helps. I am having an event generator which generates sensor readings, sensor data to IoT Hub, People familiar with IoT Hub? I apologize, I'm using the word a lot. Oh, nearly everybody is. And then I'm going to show you how do you create a stream analytics job to send it to Power BI. So the first thing I will do in order to do this is start my simulated data device. And this is doing something very, very simple. It is sending temperature between 70 degrees with plus minus 10 degree variation. And it is sending this data to an IoT hub. The next thing I'm going to do is I am going to go to the Azure portal. I apologize, I have a few screens open because I want to show you guys a few things. And in this Azure portal, I'm going to open what we call a job. A job is where you write your logic for stream analytics. So this is the job that I've created. One thing if you see in my event generator is it is sending data every 500 milliseconds. This is how I have configured it. But I want to get, let's say, only every 5 seconds, I want to get a result in my dashboard. I want to do an average of all the sensor readings which are being said. So what I have to do is, the first thing I do in Stream Analytics is I go configure my input. I say my input is my IoT hub. And this IoT hub is basically the same IoT hub that I have, which is coming from my simulated data. So once I do my input, and I can have multiple IoT hubs or event hubs as my input, then I go and I say, what is my output? Again, a configuration. I can have multiple outputs as well. In this case, I just configured it to be Power BI as an output. I hope you guys have heard or have familiar with Power BI here. Power BI actually has streaming APIs, and we write to the streaming APIs of Power BI. And then I write my query. So my query is the data which is coming every 500 milliseconds. I'm going to make that bigger so you can actually see it better. So select device ID, which is the ID which is being sent in the payload. System.timestamp as time. This is basically whenever I'm writing the result out. And average temperature as temp from into my output. And if you saw, I said the output is the alias for Power BI. From my input, input is the IoT hub, grouped by device ID. So if I had multiple devices, then it would actually give a result for each device in a tumbling window of 5 seconds. So basically, if you go back to the example that I gave, cars are going, instead of cars, replace this by events are going, and every 5 seconds, it's going to give a result of the average temperature. And the end result is just going to a Power BI dashboard. So it's as easy as that. Even when I go to the Power BI dashboard, I don't have to do anything. I just have to go and do something called a streaming API and configure this dashboard. Takes me less than 30 seconds to configure this dashboard. If time is available in the end of the session, I will actually show it. So I hope you got an idea about what is this end-to-end streaming pipeline which I had shown. Now I'm going to go into a few more things. You know, I had said you can actually put AI and intelligence on top of our streaming pipeline. I'm going to show you something very different right now. What I want to do is I want to say that I don't want to set up a threshold. Earlier I had said 50 degrees or 80 degrees. I want to have a machine learning model which is running on my streaming pipeline, which is able to detect if suddenly things spike or suddenly things drop, the temperature drops. So this is what I'm doing. I actually go and I am going to open up another dashboard, anomaly detection demo dashboard. And I am going to show you something first, and then I will basically go back to show you how you create this. You see the temperature that I'm sending is somewhere between 60 to 80, right? Because 70 with the variance. I'm going to go here and I'm going to say, let's go up to, I don't know, like 400 degrees. Certainly there is a fire somewhere. Hopefully nowhere here. But I'm updating this. So now you can see what is happening is the temperature value which is being sent is around between 460 to 480. And this is sending the value to that same IoT hub. Oops, what the heck happened? something happened in my machine. So it was sending the value to that same IoT hub. Then I had a stream analytics job. So I apologize. For some reason, the whole machine went into some kind of a mode. Okay, then I have a stream analytics job, and I'm just going to wait for this to recover for a second, and hopefully it does, else we'll have to wait for some time. The stream analytics job, what it does is it has a function that we just introduced. The function name is called anomaly detection. That anomaly detection function, what I can do is I can say anomaly detection, what is the variable that I want to detect the anomaly on, which is temperature, and how long do I want the trained model that I want to detect an anomaly on. That's all I need to do in order to get my anomaly detection model running end to end. I apologize, I have to do something here and make sure that there is nothing which is killing the process. So it seems like this is not something I can do too much right now. I apologize. So while before I can actually do anything else on my screen, I think I might have to go and recover certain things. Instead of that, can I get Ted from the machine learning team to come and show certain things and make sure that I can fix my laptop so your time is not wasted here? So what I will do is I will move the anomaly detection part and edge analytics part and TSI part of the discussion to after Ted finishes with the machine learning part of the discussion. By that time, I'll fix my laptop. I apologize for this delay, but I'm sure this is the right thing to do right now. Okay. Please go ahead.
All right, well, good afternoon. My name is Ted Wei, and I'm a PM on the Azure Machine Learning team. And so we work very closely together with Santosh's team because all the data that you're collecting needs to be processed, and you have to do something along with it. So it seems like it's a very IoT heavy audience. You guys know what IoT, ASA is. How about machine learning? Anybody played with Azure Machine Learning? Good, okay, great. Okay, so, and what do people generally use? Are you just using Azure Machine Learning or any R, Python folks? Okay, excellent. So I'll talk a little bit about just some of the basics for the folks in the audience who are not as familiar with machine learning, just to give some intuition on what machine learning is, and then just talking about what we're doing with Jabil as a manufacturing customer and how we're working with them for quality assurance. And then I'll talk about Azure Machine Learning, what we just announced, if you've seen some of the sessions from Scott Guthrie and Joseph Sarosh, the new Azure Machine Learning service and workbench on how you can build machine learning models and incorporate them into your stream analytics. So as Santosh was talking about, anomaly detection. Anomaly detection is a type of a machine learning model where you're taking in data and you're trying to predict whether there's an anomaly. So let me take a step back from that and just talk about machine learning in general. So a very, very simple question would be, if I gave you a banana, I would ask you to predict whether something is raw or ripe, right? And so let's say for a given banana, you would know two features about the banana. You would know the softness of it. You know, there's some machine that measures how soft it is, and also how yellow the banana is. There's some other machine, some camera that just measures how yellow it is. So just to kind of start building up some intuition about what machine learning is all about. So we have a scale of softness and we have a scale of yellowness based on what this machine is capturing. So we have a set of bananas that we already know are ripe. And so based on the measurements from the machine, it's fairly soft, fairly yellow. There's another banana. We also know that it's ripe. It's not as soft, but it's still kind of yellow, and we still consider it ripe because some human is determining that it's ripe. And then we have another banana that's pretty ripe. That's the softness and yellowness is here. And then we have some bananas that are not ripe, and it's not as soft, not as yellow. Another banana is very hard, so it's not very soft. It's almost green, and so it's down there. And another banana that's not ripe, but it has the softness and yellowness measurement. So basically, the idea is that you have a lot of data, whether it's ripe bananas and soft bananas. And the idea is to build a decision boundary. So what we're trying to do is find some boundary that will separate these two classes, right? And so we have a lot of data. We have data from ripe bananas, and we have their measurements. And we have a lot of data from raw bananas, and we have their measurements. And we're going to build some decision boundary so that if a banana I've never seen before goes through the machine, and it has this yellowness score and this softness score, based on where it falls in the decision boundary, I'm going to call this one ripe. And the same idea for here. Another banana that comes in, I've never seen it before, I'm going to call this one raw because of the softness and yellowness score. So at the end of the day, that's the intuition. That's what it's all about. You have a lot of data coming in, and you're trying to build some decision boundary to make a decision. And so this is supervised learning. I'm sure as many people here are familiar with, there's unsupervised, and so there's a lot of different types of machine learning models out there. But from a supervised perspective, what this means is I started with a data set, I know what's available, I know what's raw, I know what's ripe, and then I'm building a machine learning model around it. And so this is what people say when they mean train a model. And then as new data come in, you see where it falls, and then you make a decision. So where stuff starts getting really complicated is when the dimensionality of your data starts getting increased. So now you have data, instead of just 2 features, you might have 2, you might have 200, you might have 2,000, you might have 20,000 features, right? And so those are just ways in which the data, the features can be expanded. You might have a lot of different algorithms. So the decision boundary that I drew, linear, was just a straight line. But you might have a lot of decision boundaries that might be curvy lines. And when you're talking about, 100-dimensional space, the kinds of boundaries you would draw to be able to separate them makes things a little bit more complicated. So when you're picking an algorithm, all the algorithms you're picking are essentially trying to fit around this data. And the types of algorithms determine how well that performs. The size of the data is also a consideration in the sense that you imagine I only have 10 bananas, 10 ripe bananas and 10 raw bananas. And I try to build a machine learning model that predicts raw and ripe. I might overfit my data. I might overfit it based on the data that I have. So now a banana comes in, it's really ripe, but then my model says it's raw. That's because I trained it on too little data. So there's just all these different considerations to make when we talk about building machine learning models. So now, now that we have some intuition, I want to talk more about Jabil from a manufacturing perspective. And so Jabil is an electronic parts manufacturer. It's actually based here in Florida, and their goal is high-quality components. They have stuff coming off the manufacturing line, and what they want to do is prevent defects in that manufacturing process. And that way you can reduce scrap and rework, essentially. And so the approach that we took with them was that first we were looking at their assembly lines. So here they have these assembly line steps. And so, you have an assembly line. Each step of the assembly line, you do something. Maybe you put on a component. Maybe you solder something. And you do tests at each one of those steps, right? So this step, you're doing something in your manufacturing line. You do a test, moves on to the next step. You do something else. You do a test, etc. So basically, you might have multiple lines from contract manufacturers. One of them, they're building components that then get combined, and then you send it for final assembly, etc. So what they were finding was that they were seeing failures at the functional test level. So basically, you might pass all of your tests at each line step. So step 1, you do something, you get data. You test it, everything's fine. Step 2, you do something, you get data, everything's fine. And then at the end though, when everything's put together, the final functional test failed. So that's what they were facing with their manufacturing process. What they did though is analyze, okay, which products failed the final functional test, right? So going back to our banana example, it's just like, okay, we know which ones failed and which ones passed, just like we know for the banana which ones were raw and which ones were ripe. And so we took this back into, information back into the assembly line steps, and then using that, built machine learning models in between here. So basically, the idea here is that in between these steps, we were collecting data based on their existing data pipeline, and that data was then fed to a machine learning model. So just like you were taking measurements on ripeness, on yellowness and softness, you feed it to a model, and the prediction is ripe or raw. We took the data, sent it to a model, and predicted whether something would fail down the line. And then basically from an aggregation or a cascading perspective, now you can have multiple models because at the end of the day, the models are just deployed as REST APIs. So that data can come in and then it can be deployed in that way. Here's just a basic architectural diagram. So you're using event hubs to collect that data. We're using stream analytics for real-time data analytics. Putting that through a machine learning model, and then you have that feedback loop. So now, as the predictions are coming back, if in your first assembly line step, you're predicted to fail the functional test at the end, then you could scrap it. Then it's cheaper to scrap, right? Maybe all you did was put a dot of solder on it. Then you can scrap it, restart it, and then you reduce the risk of reworking or something failing the functional test. And so doing that, taking advantage of those predictions, are then ways that you could improve from a manufacturing quality perspective. So I'm just going to do a quick demo in terms of what this would look like. So everything now, we're jumping into code. So the other types of things that they're doing are also image recognition for defect analysis. So what they also have is all the telemetry that's coming off each step, but then also cameras that are taking pictures. So now you have cameras that are taking pictures, and as the components are going down the assembly line, they're taking pictures, and that's run through a model, and you're analyzing that image and then predicting whether there's a defect in that image. And so I'll walk through just some of the things that are being done when this is how you would build a model like that. So the first thing that you would do is have a set of data, have a set of good data and bad data, essentially. These are good components and bad components, right? And so going back to the machine learning process, you're creating a good data set and building that data set. And you can make use of transfer learning. And what this means is that there are a lot of featureizers out there, deep neural networks, right? If you get a chance to go to the Microsoft booth at the expo, and you've probably seen them before, where you take your picture and it does things like your age and your emotion. Have you guys seen that before? You take your picture, you see your age, emotion, gender. Yeah, perfect. So those are based off of deep neural networks. Neural networks that take the image and do a lot of processing. You might have deep neural networks that might be 50 layers, 100, 150 layers. Very, very powerful tools that you can use to extract features. So what you can do is take existing deep neural networks, such as the ones for object recognition, and then take your image, run it through the deep neural network, and use it as a featureizer. So it's essentially extracting a feature. Then instead of predicting things like your age or your gender or maybe there's an apple in this image, you take those features and then you build another machine learning model on top of that. So for all of you who already are familiar with Azure Machine Learning, maybe you're using algorithms like logistic regression, support vector machines, etc. So the features that are being extracted that you're feeding into those classifiers are instead now coming from that deep featureizer. So the idea here is that we've taken an existing featureizer, such as ResNet 50. What it's doing is computer vision, object detection, but it's also really good at extracting features from images. Then we take that, and then we train a model with those features based on the good data and the bad data, and then we're able to then predict whether an image contains a good component or a bad component. So now JBoil has the assembly line, and then the images are, the products are coming down the assembly line. We're taking pictures of it and then running it through the model, and then this model can then predict whether that's a good component or a bad component. So that's essentially what's happening in all this code here. And then you can see things basically to right here is just the feature maps of these various components. And then here's the last layer encoding, basically the idea where you are doing that prediction, where you're using the deep neural net as a featurizer. So the end-to-end to all of this, and I know we're kind of, the order is kind of discombobulated as Santosh was kind of building up on everything. We're ending with machine learning, but we're talking about the machine learning part here, is that where this fits into everything is now you have the ability to build a machine learning model, whether it's going to analyze images of things coming off your assembly line, or it's going to analyze data of telemetry collected from your assembly line, and expose that as a REST API. So if you've seen Scott Guthrie's session or Joseph Soros's session, we're making Azure Machine Learning is now publicly available. This is the new Azure Machine Learning Workbench, and in addition to the model management service and also the operationalization service. So the idea here is that from the machine learning workbench, you could use VS Code, you can use PyCharm, you can use your favorite IDE to be able to write your code, and then do things like do your data wrangling, but then you can submit your jobs onto various execution environments. So I'm building a model. I want to classify flowers. I want to classify whether components are bad or good from my machine. I can submit this and train this on a local Docker container. I can submit this as a job to an HD Insight Spark cluster to do my training, or I can submit this in the future to an Azure Batch GPU cluster. And so there's a session, I think there's a few sessions tomorrow where we're talking about Azure Batch. So the idea is that now you can spin up GPU clusters to be able to do your deep neural network training. And once that's done, you have the model artifacts, which can then be packaged as a Docker container. So you're training your machine learning model, and instead of just deploying it as a REST API onto Azure, you can package that up using Azure Machine Learning as a Docker container. Now, anything that can host a Docker container can now run your model. And this is where the IoT Edge discussion comes in. So, we're also talking about IoT Edge here at Ignite. So Sam George, I think, did a session this morning. But basically, the idea now is you have a Docker container with your machine learning model. There's a REST API on it. And now you can deploy this onto an edge machine running the IoT Edge runtime. So this is a server that could be on your factory floor. This could be a Raspberry Pi. This could be basically, anything that can host a Docker container. So now, as your data is streaming in, it's being processed by Azure Stream Analytics, or it could be just images taken by a camera. You run that through your model living on an in a Docker container, and the result, the prediction comes back. So you don't have to send these big images to the internet, or if you're like on an oil rig, you have a limited bandwidth, or if you have a super sensitive, secret, top secret, manufacturing site where data can't touch the internet, now you can do all this processing. So from an end-to-end perspective, you're able to take advantage of big data and big compute in Azure, whether it's GPU clusters, CPU clusters, train your model, deploy that to the edge, or deploy that to Azure on Azure Container Services, and you have the ability to be able to do machine learning on this type of data. So that's just a quick walkthrough on that, and I'll turn it back to Santosh to talk about the rest of the real-time streaming analytics.
Ted was talking about this. This was actually not a bug. This was actually the right flow, because I was going to start talking about anomaly detection, and I hadn't actually allowed Ted to talk about machine learning. So let's get back into the flow right now. Thank you, Ted. I hope people got a good idea of what is machine learning, what we are doing with Azure Machine Learning, and how you can operationalize it in different places. But as I was earlier talking about anomaly detection, this is one of the machine learning models which we work with Ted's team on. And instead of doing everything that Ted had mentioned that you need to do, what we took is we brought it into our streaming pipeline, and we tried to reduce the complexity of this model working for you as a customer. So let me show you how we did this. And I'm going to try this again, and hopefully my machine does not give an issue. But as you see, temperature is going between 60 to 80, and I'm basically saying, all right, now the temperature is flowing between 60 to 80. I want it to flow between 400 to 405. You see here, suddenly, I am going to see a spike. I apologize. There is a little bit of a delay here. There was some network latency which is happening. But you see suddenly the temperature went up to 400 and 405. This is just the raw data which I'm sending through the previous job that I had shown. But here is something interesting underneath that. You're seeing that there is an anomaly score which has been kicked off. This anomaly score was somewhere between -1 to 3 because I just started it. But as soon as I changed that variable, it became, I don't know, 10 or 12 in this case, and now it has fallen down again, even though my temperature is at 400. Why it has fallen down again is because the model has learned from the new data, and it is saying, what is my new normal now? Now, I showed it in an upswing. Now, let me actually show you what happens when I go down. And I'm just going to go randomly down for a different variable. And while this is going, let me show you how you configure the whole thing. I have another job, which is a stream analytics job, which is basically reading from exactly the same IoT hub. I hope you remember this part which I had shown earlier. I will show you the query. What we are doing in this query, and let me go closer so you can kind of read this better. What we are saying is we just introduced in preview a new function called anomaly detection. I want to detect anomaly over the temperature, and if you saw, I was saying temperature is one of the variables. And if you see what I have written after this, which is over limit duration of 30 seconds as score, what this means is detect an anomaly over what is the normal in the last 30 seconds. So this model, what we are telling the function is detect an anomaly over whatever you have learned in the last 30 seconds. And why this is important is I just did 30 seconds here for the sake of this demo. I could have done in the last day, I could have done in the last hour, I could have done, there are multiple windows like hopping windows and different windows that I could have done it in. But the important part here is in case an anomaly happens, or sorry, in case once I'm getting a score from this anomaly detection model, I use a variable, and there are multiple variables that we are returning as a score, which is the bi-level score in this case. And the bi-level score is basically whether something increases or decreases. Then I want to know what that score is. And I am pushing that bi-level score to my Power BI dashboard. So now you can see what you're seeing below is just the bi-level score. So even when I decrease the temperature, I didn't set any threshold, but I was able to actually get a score from my anomaly detection model until it went back to the new normal, because the new normal is at 30 seconds. So I'm not going into too much details, but I hope you understand how we are taking machine learning and embedding it in different tools like stream analytics right now. The other thing I can also do is I can also say if my bi-level score is say greater than 4, then I want to send the result of this anomaly detection model to an Azure function which sends me an email. So I can actually now start doing alerting on top of the anomaly scores that I have got. So I hope you can see how I showed you the live dashboarding, I showed you how you can detect anomalies, how you can actually look at anomalies and think about what are the thresholds I want to set up my alerts on, and then I can also go and I can set up alerts which send the result of the alerts to something like an Azure function or an event hub or a service bus topic in queue from which I can kick off my workloads. Now, any questions on this before? I'll just take one question before I go to the next topic. Was this clear? I'm just curious. Are you able to see how we are tying everything together on streaming? There is one question.
I'm sorry, maybe you should, but was the anomaly detection on a single variable, or can it also do multi-variable?
The question is the anomaly detection on a single variable, or can I also do it on multi-variables? Currently, it's on a single variable, but we are working on how do we improve it. So, all right. So let me go ahead because we have half an hour, and we will come back to more things after this. The next thing which I wanted to show is I have talked about stream analytics, I've talked about the real-time insights and anomaly detection and things like that. I also wanted to talk about a few other things. The other thing is I can not only get a single stream of data. If I have a system in which I'm getting weather data and I'm getting data from my connected cars and I'm getting data from other devices, I can actually correlate all of them using my real-time analytics pipeline using join functionality. So just like there were many SQL people, if you use SQL joins, I can use that same SQL joins on a temporal window in order to join data between streams. I can use reference data, which is data at rest, so I can augment my streaming data. I can do custom code currently with JavaScript. Machine learning models, Ted actually showed that, which I can call out to as well. Built-in troubleshooting, Visual Studio plugin, so you can actually develop all of this from Visual Studio. And another important thing is, we truly built for scale. You don't do global processing unless you build a scale-out architecture. I can partition my workloads, and I can send this partition across different compute units. So these are things which are inherently important for what we have done while building our streaming pipeline. Other things, this is based on temporal semantics. So you can think about, I can use the timestamp which is there on my payload, or I can use the timestamp when the payload was sent to the cloud, depending on my needs. I can do event ordering. One of the first customers that we worked with who was doing building monitoring basically said that, hey, I want to detect patterns on the basis of time. But the problem is, two different buildings have two different gateways who can have two different latencies of connectivity. So we have given you policies in which we wait until you say that, let's get the events from all of these gateways, all of these buildings, and we automatically reorder the data before we help you figure out what are the patterns that you need to detect. So this is managing latencies between sources. I can do also things like join data in motion with data at rest. The other thing which is very interesting, and actually I have a session at 4 o'clock after this where I have a customer coming, is connected cars. Fleet management is a very big thing which is picking up. So we are actually one of the industry's first think about as a fully managed multi-tenant real-time processing solution which has geospatial analytics built in it. I can do things such as know what is the distance between two objects. I can do things such as, is an object, is a car, or is your truck within a particular zone? When does the truck leave the zone? When does it come back into the zone? I can do a lot of these interesting things which are used for everything from connected cars, asset tracking, fleet management. This is what the customer in my next session is going to talk about. Geofencing, and I said NASCAR is also using something like this. Here are some examples of doing it. I can do things such as create an event when a gas station is less than 50 kilometers from the car. So why I'm showing you this is, even though people think, oh, in SQL you can only do so much, I showed you some examples of how I can do machine learning with anomaly detection. I also want to show you some examples of how you can do real-time fleet management, which is actually pretty expensive right now if you use proprietary system. And all of this for something, literally, the cheapest stream analytics job is 11 cents per hour. So you can kind of guess how cheap you can actually get down to be as well. All right, so I talked about the cloud. I said I'm going to talk about the edge after this. Everything that I talked to you about stream analytics, when I started in this team 2 years back, I started talking to a lot of customers, actually started with manufacturing customers. They said, you know, Santosh, it is great that you're doing all of this, simple ways to detect anomalies, simple ways to do alerts, reduce the data that we are sending. But you know what the reality is? If I have to run my factory floor, I cannot always depend for a very low latency scenario on connectivity to the cloud. If I have to do something mission critical, I have to shut down a pump because the pressure and temperature from two different places which is coming is a lot. I cannot depend in the cloud. I love your language, but I have to create a different solution for the edge. We took that learning and we worked with the Azure IoT Edge team in order to enable you to deploy everything that I talked about in streaming until now down to edge devices. There are a few things like ADE and geospatial that we are adding, but the same things like the SQL-like language, I can go to the cloud and I can write it. I can select my IoT Edge and I can deploy it. So, people familiar with Azure IoT Edge? Okay, there are a few people. There are some sessions which are happening right now, I think tomorrow, and please do attend those sessions because that is fundamentally where IoT is going as well. But Azure IoT Edge provides you things such as security. It's a cloud managed service. It is a cross-platform. I can have my Linux as well as my Windows machine. It's fully portable, it's extensible. It's not just Stream Analytics or ML that I can run on it as containers. I can also have my own custom code containers and run on it. What Azure IoT Edge enables me with is, sorry, I'm just going to, for the purposes of this discussion, I don't need to go into these details. It basically enables me to take components from the cloud and deploy it on the edge. So a version of the IoT Hub, for example, is deployed on the edge. An edge is a device, I think it is 128 MB plus devices. So even smaller than a Raspberry Pi 3 you can think about that I can deploy this on. Once I have my Azure IoT Edge, it uses things like device twin to communicate status and other things with the cloud. But for purposes of our analytics discussion, what I can do is I can take things like the machine learning model, which Ted talked about, Stream Analytics jobs, which I'm talking about, Azure Functions, if you're aware of that, and I can deploy them as containers to the edge. This is not something that we have finished and we are still working with the Edge team on, but think about the deployment model, such as you can go to AML and say, I want to create a container with this. You can go to Stream Analytics and say, I'm creating a job with that SQL-like language with JavaScript and things, and I want to create a container with this. And once you do that, you can select what are all the containers you want to deploy. You can select the target device that you want to deploy. You can review it. And when you click deploy, when the device comes online and connects with IoT Hub, automatically everything gets deployed to it. So while I'm telling you what the future experience is, with Stream Analytics on Edge, we have been in private preview since Hannover Messe and Build of this year. So we haven't really gone into this experience, which I showed you previously. But I'm going to show you a different experience of how do you create a Stream Analytics job in the cloud, deploy it to a device, manage it from the cloud, and get everything else working from the cloud, but the fundamental job is running on the device. Why are we doing this? Before I show you the demo, number one, low latency command and control. I have customers in private preview who are saying I want to use this for actually saving up to 8% wastage from production, which in certain cases is a lot. Sensor fusion at the edge. You have different PLCs. One of the hardest thing is, how do different systems which are running connecting with each other? I told you that with Stream Analytics, I can have multiple streams and join them using a SQL-like language. Compliance. I have a customer who is saying, I cannot send the VIN number, they're doing certain things, you can think in the automobile, to the cloud. So how do I strip certain things at the edge before I send it to the cloud? Intermittent connectivity. I have some customers who are actually in cruise ships who are in our private preview program right now. And they are saying, we don't have connectivity all the time. I cannot let my business die just because there is no connectivity. So how can I run some of those business critical workloads on edge devices? And of course, one customer, interesting, I think they said they look at vibrations. They generate over 50,000 vibration settings per second, per device. I don't want to send all of this to the cloud. I want to be able to aggregate some of the data on the edge device before I send it to the cloud, right? I would have loved to bring a device and do a demo here, but for purposes of showing what needs to be done, it's easiest to show it on a BI dashboard, just because then you can see the direct impact of it. What I'm going to do in my demo, and I will walk through the slide a few times while I'm doing my demo. I have two jobs, Stream Analytics jobs. One job, which I call JS_PPR_Power BI, is a job which is only running in the cloud. I have another simulator which is running on my laptop, which will act like it is simulating sensor data from multiple sensors. And there is a gateway, Azure IoT Edge. I have deployed it on my laptop, which connects to IoT Hub. and sends the sensor data from here to the IoT hub. What I'm also going to show you is another job, which is called ASA Edge PPR. Now, the interesting thing about this job is that this job does not run on the cloud. It is only created in the cloud, and I'll show you that by showing you the inputs and outputs of the job. But whenever I manipulate this job, you will see changes in the Power BI dashboard. What means is, whatever manipulation I do here is actually running on my edge, okay? I apologize, this is not as dramatic because I'm not having some devices, but if there are any questions, please do ask on this. So let me go and, first of all, show you, this is my simulator, which is running. And in my simulator, I'm sending things such as average temperature and average humidity, if you can see this. Okay, next I am going to go to my BI dashboard. And I'm going to show you the BI dashboard, which is my Edge PPR dashboard. Now, the interesting thing in this dashboard, and you know what, the resolution is too high. I'm just going to decrease it so people can see it more clearly. I think people can see it on the screen now. And you see that every few seconds, you're getting a result from my Edge device. I told you there are two jobs. There is one job, which is the JSPPR Power BI job. This has the input of the IoT hub, which my laptop is sending the data to. And this has the output of the Power BI dashboard, which I just showed it to you. Now, I'll show you the query as well. And the reason I'm doing this setup is to show you what is the differentiation between the cloud and the edge. The query is actually pretty straightforward. I'm basically saying that I want to get the average temperature, average humidity from my input into my BI dashboard. That's about it, very simply, that this query is doing. Now I'm going to go to my edge job. What is the input of my edge job? The edge job input is basically the data which is coming on the bus. And this is the Azure IoT Edge bus. The output is also the data that I'm writing out to the bus and what is the format that I am actually writing out this data in. The other thing that I'm doing is I am saying what is the device that I want to deploy this particular job to. Now, if you look at this, it is connecting to an IoT hub, and it is saying the name of the device is my first device. Okay? Now, if I go to the job, which is the query which is running is very straightforward actually. And I have to go here to show you the query. Select temperature as average temperature, humidity as average humidity into output from input. Doing no processing. And this is why, if you look at the Power BI dashboard, what is happening is every time there is a temperature or a humidity thing which is generated at the device, it is sent to the cloud. Okay? Now see the job that I'm working on. I'm going to stop this job, and this is the job which I am running in the cloud, on the edge device. I go to overview. I stop this job. And the job is stopping. What this means is I have just triggered the job which has been running on the edge device to stop. And you can basically see it here. You don't see any inputs anymore. And you saw that I didn't do any changes to the things which are happening in the cloud. Now I go back. I am going to comment this out. And I already wrote this query for the sake of making it faster. And I'm going to say, remember the last scenario that I talked about where I don't want every data, I just want to aggregate the data and send it to the cloud on the device. I'm saying I want an average temperature, average humidity every 10 seconds. I save this. Now, actually I'm just going to click start. And I want to start now. And let's look at the BI dashboard. You saw I didn't make any changes to the cloud job. Let us see what happens in the BI dashboard. What is actually happening right now is the edge job is actually deploying the package or the container that we are talking about to, unfortunately this time the device is my laptop, but imagine it could have been any other device. It could have been a Raspberry Pi that I'm deploying it to as well. And once that happens, you will see that the reading that you were getting every second or every 500 milliseconds or whatever frequency, now this same Power BI dashboard is only getting updated every 10 seconds. And I'm going to show you also in the simulator. The simulator, which was actually simulating data very frequently, is now simulating data or the results only every 10 seconds and sending the results to the cloud. Not only this, but I can also monitor this data directly from the edge. So here, the monitoring takes, I think, like a minute before it catches up, but I can actually monitor how many events came in to the edge device, how many events were pushed out from the edge device, in case any issues happened in the edge device, all of this from the cloud. So I hope this gives you an idea about what I was talking, or I'm talking, where I can use the cloud, I can use the same language in which I'm creating my logic in the cloud in order to define it, say what devices or which device or set of devices that I want to push this job to, run the job, and when that happens, the job automatically runs on the devices. Without me making any change to the cloud, I'm impacting just the job running on devices. Any questions on this before I move on? By the way, this experience will change. This is only for private preview. We are working with the Azure IoT team in order to make a different experience, but the fundamentals of creation and management is going to be the same. There is one question. Great question. The question is, where do you manage what goes to what device? This is right now, when you saw in the private preview, when I clicked on devices in my job, I can write it there. But when we are working with the Azure IoT team, in order to work on an experience, which is very similar to this experience, I will actually show you that. This is the right one, yeah. It's going to be something like this. Oops. Okay, where I can basically say which are the jobs or which are the containers. The job basically becomes a container, Docker container in this case, that I want to deploy to different devices. I can select what are all the target devices that I want to deploy it to, not just one but multiple devices, and this is how it will work in the future. All right, the last thing that I wanted, I hope people got an idea of how we are tying the cloud and the edge together and AI together with all the stream analytics things that I talked about. We are working with customers or partners such as HP. So in Hannover Messe Build, HP actually came on stage with me and they bought basically a vibration sensor and the HPE edge device. They had jobs which were running on the edge device, and this is where they were reducing the data before sending it out to the cloud, or they were doing alerting whenever issues happened with the vibration sensor. Again, why is it differentiated from the other edge and cloud offerings? Number one, same language. Number two, cloud management. Number three, works on multiple platforms, Linux platforms, Windows platforms, multiple protocols with Azure IoT Edge. And it will work with everything else that you deploy on the edge, be it machine learning, Azure Functions, your own custom models as well. The last thing that I wanted to talk about is time series insights. So we've talked about data in motion, we've talked about machine learning, but you know, something interesting happens. I have just detected the anomaly. I just got the email that suddenly temperature spiked or decreased. How do I go and do research about it? One of the things that happens in the IoT domain is there is a lot of data which is actually generated from sensors. Multiple problems. One, this data is sometimes just in different silos. I have different factories in which this data is being got. Then I have to figure out a way to bring all of this data together. Number two, I need to do a lot of data prep before I can even compare things together, right? I mean, I'd literally have to go and figure out what's the schema of different things, how do these schemas match together, then I need to get my time series indexing, and only then can I measure and see what is compare and contrast, what are the issues between them. Visualizing IoT data at scale is actually very hard. Think about millions and billions of events which are coming every day from your geo-distributed factories. This is why we built Time Series Insight. It is a storage, analytics, and visualization solution all in one for your IoT time series data. We have a lot of scenarios, everything from root cause analysis, anomaly detection, unified view across different plans, so your geo-distributed plans, validation and monitoring. We have a customer who actually decreased the amount of time it takes to validate that a new sensor that I add to my production line is working properly or not from 2 days to less than 30 seconds with Time Series Insights. And I'll show you how they did that. And you can also embed this in your own application. So what I wanted to do very fast is show you a demo of Azure Time Series Insights. Question, have any of you guys seen or heard about Azure Time Series Insights before? Perfect. Any of you guys came to Sam George's session earlier today, 9 o'clock? Just one person. Okay, few of you guys. Sorry, it's going to be a very similar demo to that which I did there. So in this demo, what I'm going to do is I'm going to put myself in the shoes of an engineer who works for a factory. And what I've been told is, hey guys, there is an issue that you have to look into in your production line. And you've got to optimize this production line for me. So the first thing I have done is, just as all the demos I've shown today where sensors are sending data to IoT Hub, imagine now I have multiple factories, geo-distributed factories, which are sending data to a single IoT Hub, okay? The next thing I do is I basically go to the Azure portal, similar to the place where I went and set up stream analytics and other things like machine learning. And I go and set up something called an Azure Time Series Insights environment. I go and say, what is my IoT Hub that the data is coming into? I can also add reference data. So I can basically say the data which is coming into my IoT Hub is only sensor ID and value, but I want to augment it with more information, such as what is the location, what is the space, which factory it is coming from, and things like that, because I don't need to send all of this data again and again. So reference data is data at rest with data in motion. Once I do this, and this is the only configuration that I have needed to do, after that, my next experience is literally going to this portal, and what you see in this portal is data which is coming from multiple factories, and these are millions of events which are coming per day. And now I can basically go and say, there was an alert which got kicked off at some point in the last 4 days or 5 days. So I can basically click here. I can go and say search and see, first thing, 7 million events. In less than a second, you were able to see this. Number 2, you're just seeing a count of all the events, completely useless. Because you can't really know what it is. Important thing, I did not do any data prep. This, one of our IPs that we have put into this particular service is we are schema adaptive. We learn from the data which is coming into the system. So I am able to automatically infer what are my measures and dimensions. So I don't even know what data it is, but I can say, there are different types of data which is coming. Interesting. There is pressure, temperature control, temperature, vibration, production line, temperature alerts. Alerts are also being pushed into this IoT Hub. Again, I haven't set up these things. I'm just literally going through the system. I have to go and look at some production line, right? I see production line. Okay, now I can look at by factory or station. Let me do it by factory. Interesting. I see that factory 1 and 2 is okay, but the production of factory 1 and 3 is okay. Production of factory 2 actually fell on a particular date. Okay. Important part of time series analysis. You need to be able to compare and contrast different variables, facts, dimensions on the same time scale. So now I can create a clone and I can say, let me look at alerts on that same time window over the same data which is coming. And what I see is when my production line started becoming low, my alerts started firing. I can go and explore the events. Important part of time series insights. None of these aggregations, none of these analytics is actually pre-computed. All we have is the data. Everything that we are doing is on the fly, the computation on the raw data. I can look at the raw data and say, my alert is because of a high temperature alert, right? Okay, I'm getting some ideas, Production line decreased, alert says temperature. Let me go add temperature here. So now I'm going to go and see what happened to my temperature during that same day. So let's go down, let's select temperature. I'm just going to do it by factories. Interesting. My temperature in factory 2 had some variation when all of these things happened. You know what? I want to look at what is the min-max so I can actually see the boundaries, not just the aggregates of information. Okay, my temperature in factory 2 spiked at this time. So you saw, I'm going through this narration because you can see that without knowing too much about the data, I can start exploring things on the same time window. I can start doing some analytics on top of it and visualizations on top of it. By the way, one of the SLAs that we have for time series insights is within 1 minute, we will ensure that the data that is in IoT Hub that you have sent will be available in time series insights with your historic data. And this is for the millions of events that you're sending per day. This is our guarantee to you. So thank you. Not only do we do that, the other thing that you can do is, we learned that there's a lot of sharing that happens when you're doing a lot of collaboration. So we allow you to save these views and share it with other people in your organization so you can collaborate. For example, in this case, imagine I had shared this view and shared it with somebody else, and one of my colleagues, Andrew, did some more research and said, hey, you found out there's an issue with factory 2. Let's dig a little more into it. So he bought out the alerts, temperature control units, temperature, pressure, vibration. Now visually, I can look at this and say, my production decreased when the alerts started firing. Let me zoom into this a little more. Interesting. Alerts started firing when my temperature increased, which is the orange line. Pressure, no impact. Vibration, no impact. But I was not monitoring my temperature control unit. And literally, you can see that the temperature control unit started falling before my temperature increase. What did I just do through this? What I figured out is the cause and effect based on a temporal window using very simple analytics. That is what time series insights is. Now I can go and set up a better production line using something like stream analytics in order to set up alerts on my temperature control unit. So I hope you get an idea about how time series insights kind of allows us to play very easily with the data, real-time, historic data. How do you compare things? One of the interesting things which I did not mention, and I have 2 minutes, so I'm going to mention this as well, is we have also provided things like heat maps on top of it. So in this case, rather than starting from the factory, I started with temperature and all the sensors which are sending the temperature value. It's only between 29 and 30 degrees, but my dad was a chemical engineer, and 1 degree change can actually impact your production quite a lot. So what we have done is visually we inspect the data and show you in a period of time what are the anomalies on the different variables which are sending the data, sensors which are sending the data in this case. So I can see here, these sensors were okay, but there was one particular sensor which was hotter than the rest of them. I can zoom into this. I can literally go and explore the events. And everything which I did before, I could have done even through this kind of an interface, where I now know I have to go and dig into factory 2. Right? Because I started with the heat map. So there are multiple other things. There is reference data that I have here. There is one other interesting thing that I could show you as the last thing before leaving, because I actually am excited about it and I find it interesting. I can look at, I can select some range of data and I can say, show me the stats over this range of data. And once I say, show me stats, oops. My screen is, okay, let me explore the events. We actually detect patterns automatically in that data events that you have. So here you say things such as, from the data that you are sending, 14% of them is temperature, 24% of them is sending pressure values, These are important things in order for you to do your time series analytics as well. So those are the main things that we wanted to cover today in our session. I hope you got an idea about how using Azure, starting with Azure IoT Hub, Azure IoT Edge, services for real-time analytics like Stream Analytics, Edge Analytics, time series insights, and machine learning, you could actually build an end-to-end solution for your IoT needs, and you can customize it. Thank you very much, guys. Okay. I think yes.
Time series insight, the steps you're taking to kind of find the root cause, are those steps recorded somewhere that you can apply to a different time frame?
This is a great question. So in time series insights, the steps that I'm taking to find the root cause, are they recorded somewhere? I can actually save my query, and I can actually have something called a perspective view, and I can move my time window so the same perspective view goes over the time window. So, sorry, I have to run to another conference center for my next session in 30 minutes. So, any? Yeah.